Hello everyone. In this video, we are going to see another problem in power electronics. A 220 volt, 1400 RPM, 40 ampere, separately excited DC motor has an armature resistance of 0.4 ohms. The motor is fed from a single phase circulating current 2-volt converter with an input AC line voltage of 220 volt RMS. The approximate firing angles of the 2-volt converter for motoring operation at 50% of rated torque and 1000 RPM will be option A 43 degree, 137 degree, option B 43 and 47 degree, option C 39 and 141 degree, and option D 39 and 51 degree. So this is a multiple choice question. We need to find the answer and tick the correct option. The solution of the given problem is given here. We know that for a dual converter, alpha 1 plus alpha 2 is equal to 180 degree. So keeping this in mind, we have to find out the firing angles. Now, the rated back EMF, we need to find out the rated back EMF, which is ER equal to VR minus IR RA, where VR is the rated voltage and IR is the rated current. So 220 minus rated current is given as 40 into 0.4. RA is given as 0.4, which is equal to 220 minus 16 equal to 204 volts. So rated back EMF is 204 volts. Next, we need to find out the back EMF at 1000 RPM. Because in the given problem, we are asked to find out the firing angles at rated 50% of the rated torque and 1000 RPM. So we need to find out the back EMF at 1000 RPM, and then we need to take the current for half the rated torque. So back EMF at 1000 RPM will be equal to 204 into 100 by 1400, which is equal to 145.7 volts. This is the back EMF at 1000 RPM. And it is also given that the armature current is, we need to take the armature current at 50% of the rated torque. So armature current at 50% of the rated torque will be the rated current divided by 2, or rated current into 0.5, which is equal to 20 ampere. Now for this armature current and for this back EMF, we need to find out the armature voltage. Armature voltage can be written as back EMF plus IARA. Back EMF, we found it as 145.7, and the armature current at the rated of the rated torque, we found it as 20 ampere. So 145.7 plus 20 0.4 will give the required armature voltage as 153.7 volts. Now, this is the armature voltage, required armature voltage to produce the the speed 1000 RPM and to produce the 20 ampere. Now, this VA is being supplied from dual converter. So we need to find out the firing angle corresponding to this VA. So for a single phase fully controlled bridge converter, a dual converter is constructed with two full converter connected in anti-parallel. So the average output voltage of the full converter, we know that it is equal to 2 Vm by pi cos alpha. So substituting the value of Vm and taking this VA is equal to VDC is equal to 153.7, we can find out the cos alpha. So initially, so we have to take here Vm, we need to take as root 2 into 220, which is equal to 311 volts, and 2 Vm by pi. So substituting Vm and VDC, we get, so 2 Vm by pi, we can find it as 2 into 311 by pi, which is 198 volt. So equating VDC equal to 153.7, we get the cos alpha as 0.776. Alpha is now equal to cos inverse of 0.776, which is approximately equal to 39 degree. This is the firing angle for one converter. Let us take the firing angle of first converter, alpha 1. So we know that alpha 1 plus alpha 2 is equal to 180. So alpha 2 will be 180 minus 39, which will be equal to 141 degree. So the correct option will be 39 degree, 141 degree, which is given in the option C. So the correct option is C. the correct option will be C, which is 39 degree and 141 degree. Thank you.